guys. So today we're just going to talk about how we're going to be able to identify when certain shapes are parallelograms. I'm not going to go into crazy formal proofs, not today. We will get into crazy formal proofs. But today we'll just talk about some of those things. But some of those terms will come up, like the angle, side, 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 those types of things. So don't be too intimidated by this. It's going to be pretty straightforward today, okay? So we're going to be identifying parallelograms. So let's just real quick, how do we know if something is a parallelogram? Well, parallelogram, okay, and what I'm going to compare to over here is a trapezoid, because that is kind of like the closest thing we have. Because if it's got some of the characteristics of the trapezoid, it might be a parallelogram. But remember, a parallelogram, two sets of parallel sides. A trapezoid has one set of parallel sides, okay? A parallelogram has diagonals bisect, okay, trapezoid. An isosceles trapezoid has diagonals that are congruent. Okay. Parallelogram has opposite sides are congruent. Okay. And again, I'll say an isosceles trapezoid has one set of congruent sides. Okay, so real quick, if you see one set of congruent sides, is that enough to prove something's a parallelogram? No, it might be a trapezoid. We don't know. You really need to show that both sides are. If your diagonals bisect each other, can it be a trapezoid? Yes. If you have diagonals that are congruent to each other, can it be a parallelogram? Yes. In fact, it could be a rectangle or a square. But that is not a defining characteristic of a parallelogram. So again, if there's some of these rules that you guys don't remember, please go back and watch the intro videos on parallelograms and trapezoids. And what was there was one? Oh, let's go consecutive angles are supplementary. Okay, and a trapezoid you have pairs. Okay, so just to kind of show you guys what some of these things look like, if we had a trapezoid, an isosceles trapezoid here, okay, and then over here we had a parallelogram. Again, you have two sets of parallel sides here, right? Left and right and kind of up and down. And you only have the one set here. Your diagonals bisect each other, meaning if I draw the diagonals, they bisect each other. But again, they cut these into equal parts, but they're not all equal, right? Clearly, this is a long distance and this is a short distance. In an isosceles trapezoid, though, they are congruent. Okay? Now, just again, like I noted before, if you had something like a rectangle, and we'll get to additional properties of rectangles. A rectangle is a parallelogram, and the diagonals are congruent. Okay? So if you can prove it's a parallelogram, and you can prove that the diagonals are congruent, then you can also prove it's a rectangle. Okay? And your opposite sides are congruent. Again, here with a trapezoid, you have one set of congruent sides if it's isosceles. Any two consecutive angles in a parallelogram are going to be 180, right? I can take any two in a row, right? Take 1, 2, or 2 and 3, or 3 and 4. And a trapezoid, that is not the case. What you have is on both sides, right? These two will be 180, and these two will be 180, right? And if it's an isosceles triangle, you can take it a step further and say the top two are congruent and the bottom two are congruent. All right, so let's take a look at some questions. Okay. Can you show that this is a parallelogram? Well, what did they tell you? They told you have one set of congruent sides. That is not enough information, right? That is not enough information because essentially what could I say is that, well, I can say it's an isosceles trapezoid, couldn't I? Now, it's not typically how we draw it, but what are the defining characteristics of an isosceles trapezoid, right? And in fact, we can say it doesn't even have to be. It can be just a regular plain old quadrilateral. So can you show this is a parallelogram? No, there's not enough information, okay? And we'll talk about specifically how you're going to find some of that information for these, okay? All right. Can you show this quadrilateral is a parallelogram? And you're going to be tempted to say yes, but let's take a look. This side right here, now I have one stripe and two stripe on this diagonal, and one stripe and two stripe on this diagonal, which means that these two, we'll call them, let's give them some names. Let's talk about what we know. We know that AC is congruent to BD, right? Our diagonals are congruent. That is a characteristic of a trapezoid, okay, an isosceles trapezoid. Again, could this be a parallelogram? It could be. It could be a rectangle or a square, but do we have enough information to show that this is a parallelogram? No, we need more information. Okay, there's definitely not enough to show that this is the same. Okay, we can at best prove it's a trapezoid. Okay, can you show that this quadrilateral is a parallelogram? Yes. Okay, you've got two sets of opposite sides. That is enough. So again, I know I told you guys we wouldn't get too far into triangle proofs, but what if I did this? Okay, now let's give these triangles some names. Okay, you guys see there? You guys should see that there are two triangles there. I've got triangle ABC and triangle CDA. Okay, and again, what can I say now? Well, I can say that these two triangles are congruent because side, 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 right? They gave you the opposite sides being congruent, right? Those two sides, and you drew this diagonal to prove a third triangle, third side of the triangle is congruent. So again, what does that let you know? That lets you know that all the angles are the same, right? Well, that means that B is the same as D, and it lets you know that that C and A are the same, and all of a sudden now we have everything we need, right? Now we have the alternate interior angles, the sides are parallel, and everything kind of falls into place, okay? So again, when you see the two sets of opposite sides, that's a surefire way to tell that this thing is a parallelogram, okay? Here, can you show that this quadrilateral is a parallelogram? Yes. Okay? Again, let's give it a name, we'll call it A, B, C, D, and E. Well, AE is congruent to EC. And I also know that BE is congruent to ED, meaning the diagonals bisected one another, right? And again, is that enough information? Well, yeah. Well, I know vertical angles too, right? So let's think about this for a second. I know that this angle is the same as this angle, and this angle is the same as this angle, right? Well, now I've got side, angle, side, side, angle, side. So yes, I do know that this triangle is the same as this triangle, side, angle, side, and this triangle is the same as this triangle, side, angle, side, which tells us something. It tells us that this is the same as this, is the same as this, is the same as this. So in fact, we know a little bit more now. We actually know that this is even, could be a rhombus possibly, okay? Okay. The other questions say, what value will make this a parallelogram? Well, I know that these sides are congruent. Well, from our other problems, we also know that if these sides are congruent, then it has to be a parallelogram. So now it's just a matter of, let's go ahead and let's solve this. So 3x is equal to 6, and x will equal 2. Is that what they're looking for? Yes. Okay, so those are similar to the problems we did last week. Again, here, whatever value of s makes this true is going to make everything true. So I would take a real quick look at this and say, which one of these is easier to deal with? Do I want to deal with these two being congruent, right, or these two being congruent? I'm going to say these two. In fact, it really doesn't matter. You can use either set. So I'll say 3s minus 6 is equal to s is 46. And again, let's go ahead. Let's add 6 to both sides. 3s equals s plus 52. Subtract s from both sides. 2s is equal to 52. And again, like half a deck of cards, half of 52 would be 26. Okay, so what value of s is going to make this true? 26. That's about it. Okay. Please, the one thing I can emphasize to you guys, don't use the eyeball test. Don't look and be like, yeah, that's a parallelogram. No, absolutely not. Not acceptable. Okay. You can't just use the eyeball test. You're going to have to do some work. You're going to have to do some thinking. Okay. So get these done today, and we will pick it up with some more advanced stuff tomorrow.